Alright, hello you crazy people out there, this is DragoniteSpam, and this is something that I think is pretty interesting in GameMaker, but I don't see a lot of people cover when they do their lesson tutorial things, and I think a lot of other people will be interested in it too, controller input. So, I have this example over here, this NPC talking to people thing that's sort of become my default like GameMaker demo that I use for a lot of these examples recently. I have a 360 controller plugged in, and over here on my other screen, I have this thing. And this is basically just a window that I made in my free time before I started recording this with a bunch of information. It has a couple information functions about the controller, like a button count, access count, that sort of thing. It has the button checks. It checks like pressed and released and stuff. And it has the joysticks. In case anybody wants to just have a look at this particular program, I'll be putting this up for download in the description of this video. I don't know what just happened here, but nonetheless. Anyway, before I get too carried away, if I can find out what happened to the window here. That's Skype. Okay, so this is the one I'm looking for. But before I get too carried away, I'm going to be breaking this up into 3 sections in this video. In the first probably 5 minutes or so, I'm going to be talking about this device is supported, get connected, description, all that sort of thing. Just general information. Probably the next 10-15 minutes is going to be talking about button checks. Well, maybe a little less than that. But after that, I'm going to be talking about button checks. So you can tell if A, B, X, Y, whatever is pressed, all the up and down triggers, D-pad, pressing the joysticks, whatever. And then at the last, this is probably the longest part, but in the last part of the video, I'll be talking about the joysticks and the math that goes into there and like working out how to use them and stuff like that. So if you're interested in a specific part of controller input, you can just go and click on one of the annotations on the screen right now and it'll take you there. Anyway, let's see. I'm going to want to get my recording window back up on the other screen here so I can make sure it isn't not working. To start with, I'm going to go make myself another room, and we're just going to call it like test or something like that. And I'm going to go stick it in the front because we're not going to be diving right into the main project right away. I'm going to make myself another object, and I'm going to call this controller. And this is quite simply going to go and, let's see, go into the draw event. And I'm just going to draw some text on the screen. And just give me a minute to set up the shell here. Alright, there we go. So we might as well start at the beginning. Gamepad is supported. This doesn't actually have anything to do with the controller itself. This tells you whether or not the device you're playing on supports controller input. So obviously Windows, Mac, Linux, if you have it set up properly, does. Some mobile... It is possible through some jumping through hoops. I can't remember exactly how it goes. Even some mobile devices, if you have some certain setups going on, it's possible to have controllers running around. But to make a long story short, if you just want to be safe, you can check Gamepad is supported. And I did not put one of these controller objects in my test room. I'm smart. Alright, so pretend I didn't do that. There we go. I returned to 1. Windows does support gamepads, and that is all we need to know. Now, let's see, the next function I suppose that we would want to know is going to be... The next one's going to be Gamepad Get Device Count. And not unlike the other one, this doesn't actually have to do with the controller itself, but this is going to tell you, if I'm going to run the program, how many controllers your particular operating system machine can handle. And Windows, as it happens, can support up to 4 controllers at the same time. I think Mac can do 4 as well. Other operating systems, I'm not too sure. If you're writing for other operating systems, you're probably going to want to run that function to check yourself, just in case. Moving along, you can say Gamepad Get Description, and this isn't the most useful function ever. What this does is it actually returns a string, and that's going to have information about the controller. For example, mine's going to be Xbox 360 controller, X input, standard gamepad. You can't exactly program anything around that directly, but I guess it can be useful to put information on the screen for the user's benefit or whatever. Also, this does take 1 argument, and this is going to be getting into handling each controller itself. It's going to take 1 argument that's going to say device down at the help line, and that's going to be checking the specific controller that's plugged in. You can have 0 for the primary 1, 2, 3, and 4, etc. for the other controllers. Unfortunately, I only have this one 360 controller, so I can't demonstrate what will happen if you have like a 360 and a, I don't know, PlayStation DualShock plugged in at the same time. But if you also happen to have a I don't know, DualShock plugged in to a second USB port or something like that, and you were to check the description of one, it would say like DualShock input gamepad, whatever. I don't know what it is off the top of my head. Anyhow, next, somewhat more importantly, you're probably going to want to say, can I get this right on the first try? Button count. And I suppose, to be fair, if you're working with a controller, you should probably know in advance how many buttons is on it. But in case you really wanted to find out, you could do a Gamepad Get Button Count. So the 360 has, if I can get them all, A, B, X, Y, start, select, well, back select technically, left, right, LB, RB, left stick, right stick, D-pad up, down, left, and right, and I think that's it. And that's going to be 16 buttons that you can work with. That should be fairly standard on most controllers these days. I know the PlayStation DualShocks really have pretty much the same number of buttons, they're just arranged slightly differently and they're called slightly different things. But once again, that can be a function that's somewhat useful to have around. Next, similarly, access count, that's going to be dealing with the joysticks. In this case, I actually don't know of any controller that has 3 joysticks on it, but left and right, both horizontal and vertical, that's 4 axes that this thing has to work with that you can do math on. Pretty simple there. Axis count is going to be 4. I'll be getting into that later, as promised at the end of the video. Next, you can actually set the vibration for a controller. And I can't really show you this on the game window, I don't think. So I'm just going to say, for a quick example, let's make the right motor and left motor both 1. And I'm going to put my 360 controller on my desk right now, so at least you'll be able to hear it vibrating when I run this. So this is going to sound really bizarre. Yeah, you get the idea. In case you happen to want to work with controller vibration, you can do that. Maybe when you die or something, you're probably going to want to put it on a timer so it's not vibrating forever and it goes off after like half a second or whatever it may be. But nonetheless, you can do that, which is fairly funny, I guess. There is one more general function, if I can spell it right, that you can use, and that's going to be setting the color. So I'm going to take that index 0, and I'm going to make the color pretty much whatever. And some controllers have like LEDs on them that light up different colors to tell you, like, I don't know, what player number you are or whatever it happens to be. This one that I have here does not, but should you be using a controller, should you be programming for a controller that does support that, you can make use of that. So player 1 can be red, player 2 can be blue, player 3 can be green, whatever it happens to be. You can see down here in the console window that it's like setting color in every step, so this is probably not a code you want to have in the step event, but that's neither here nor there. Anyway, that's all the boring information stuff. Moving along to the interesting things, we can start checking button input. Alright, as with the keyboard keys and stuff, you could say gamepad button check. And let's see, is this I don't want to get rid of that parentheses. There's a bunch of button constants you can use. If I were to say GP underscore, I would be able to bring up the code help with a bunch of them in it. A, B, X, and Y on the 360 controller, the star, or whatever the symbols on the PS3 controller, they're going to be represented by face 1, 2, 3, and 4. Face 1 is going to be A, face 2 is going to be B, face 3 is going to be X, and face 4 is going to be Y on the 360 controller. And if I were to run over here in the manual, I'm going to see that 1 is the cross, 2 is the circle, 3 is the square, and 4 is the triangle on the PlayStation DualShocks. So I'm just going to run the game real quickly, and I'm going to go and hit A, and indeed it's showing 1 when it's pressed down, which is of course meaning true. So that all works. Phase 2, 3, 4, I don't think I have to go through all of them and explain them. For the most part, they're all pretty much the same. The only button that you can't make use of is the Xbox symbol in the middle. But between the other bunch of buttons on the controller, you should have enough to do whatever you need. Now a very similar function that only behaves differently in 2 very specific cases is going to be gamepad button value, and this is going to be for checking. Let's see, what is it? GP. This is going to be checking what the constants identify as LB and RB, and you probably recognize better as the bigger triggers on the controller. Which I think should actually be named just L and R, and the little smaller one should be LB and RB, but I'm not sure about that. It's vocabulary here. But if I'm going to run the game, and I'm going to check for the value here, you're going to be seeing that it's a decimal going between 0 and 1, and that's going to correspond to how much I'm pressing down on the trigger, because those buttons are rather soft and not like either binary, pressed or unpressed, the way the others are. If I were to just check the little trigger, you can see that it's either 1 or 0, there's nothing in between. And I don't think this is the most useful function ever for dealing with controllers, but it is something you may want to be aware of, that you may want to be able to make use of when programming with them. So I just did want to mention it here. Now, similar to the way keyboards work, like I compared this to you before, you can also check whether something's been pressed or released. So I'm going to say GP face 1 to make it easy. Not GP face 1, just one prefix there. And I'm going to run the game. And you can see it flashed 1. It flashed true very briefly when I first pressed down on it. You can also use released. This is something that they added to controller usability in GameMaker Studio. When working with controllers in previous versions of GameMaker, you did not have access to these two functions. And if you wanted to find out if something was just pressed or released in that particular frame of the game, you'd have to manually check it yourself and like save a variable to see if the button was being pressed down in the last turn, and if it wasn't, well, you get the idea, it wasn't fun. So it's really nice that they decided to add these two. In any case, moving on from this. Alright, moving along. I suppose it's high time to start displaying this in the game. But let's see, we're going to be going into main, putting that first. And let's see, the controls, we're going to go into player. We're going to go into step. I'm going to switch this around just a little bit to make this an if-else statement instead of a switch statement. So if you'll give me a few minutes to do that. There we go, it's now in a branching if-else tree. It's not quite as neat looking as the switch statement, but it still does exactly what it's supposed to. Mashing the buttons and moving around and stuff. Now, if you wanted to work with controllers, instead of using keyboard checks, you would use, as you would expect, gamepad checks. And I'm going to be saying real quick, gamepad. Normally you'd probably want to use the controllers for moving around, but I'm going to get to that in a minute, right after I finish with this. So for left, I'm going to be saying GP pad L, so that's going to be on the D-pad. Right is going to be pad R, as you would probably expect. Down is going to be down, and up is going to be up naturally. So if you give me another moment, I'm going to just type all this out. Alright, there we go. All the D-pads are where they should be and stuff like that. So I'm going to be moving around on the 360 controller with the D-pad and just doing what it's supposed to. In this case, the way I did it here, the keyboard controls aren't going to work anymore. If you wanted to still work with the keyboard controllers or the controller controls, that sounds really weird. You could just throw a simple OR in here and you could check for keyboard input as well. But nonetheless, that's the basic implementation here. To go into NPC where you get talked to, where is it? Oh, hit space. I'm going to go and change this to the step event real quick. And I'm going to just throw this in a simple if. One of these fancy things, so it does exactly the same as before. It's just being checked for in a slightly different part of the game. But once again, if we want to convert that to controllers, we can say gamepad button check and device 0. And how about face 1, because that's the A button, and that's probably what most people usually want to use. So I am going to start the game. I'm going to walk up to this dude. Hey, how you doing? Oh, come on. I'm saying button check instead of button check pressed. Which is slightly important distinction there. So I'm going to be trying that again. And I'm going to be running up to you. Let's get out of your face a little bit. Yes, we're checking button, and it works just like it did before. Wonderful. So that's that. Now I'm going to be starting to move on to joystick testing. So if you'll give me a moment, well, not really. I'm not going to edit any video, but we're going to go back into here, and we're going to uncomment that. I don't know why it was commented before, but to start with the joysticks, the analog sticks, whatever you want to call them, you could say gamepad axis value, and that's going to take 2 arguments, the device as always and the axis index. And unfortunately, for whatever reason, GameMaker doesn't really tell you exactly what these axes are, but if we're going to run the game, let me start out here. We can see we're back in the gray room, and if I were to move left and right on the left joystick, it's showing up, the value is showing up. So from that, we know that if we were to use any of the other 4 joysticks that we were told earlier that this device has, 1, 2, 3, 0, 1, 2, or 3. 1 is going to be left, up, and down. 2 is going to be right, horizontal, and vertical. Right, horizontal, sorry. And 3 is going to be right, vertical. And if we were to check that, I'm actually going to put these all on the screen. I'm going to draw all the values on the screen at the same time so you can see a little bit more. Give me a moment. Alright, there we go. I also labeled them just to make them a little bit more clear. Anyway, we're going to run the game here. And now we have 4 values on the screen, and you can see left horizontal, left vertical. I kind of wish I had a camera pointed at the thing so that you could see where my fingers are moving and stuff. But anyway, right horizontal and right vertical. Alright, now you may be noticing that even when, I'm going to toss this on like the floor right now, but even when I'm not pressing anything, they're not zeroed out. And that is due to things like little imperfections in the plastic. Maybe, I don't know, maybe there's a little tiny bump that causes the stick to not snap to the center and be off by like a couple millimeters when you take your fingers off it. And to deal with that, that is something you're going to want to deal with, because a lot of people are going to find that pretty annoying if they take the fingers off the sticks and the character is still walking around very slowly. You could use this function that says Gamepad Set Axis Dead Zone. That was very conveniently on my Windows clipboard. So all I have to do is copy and paste instead of write it out. But anyway, the device, as always, is going to be the first argument, and then the dead zone. And what this is going to do is any value that Gamepad Axis Value gives you that is below this specified value, well, whose absolute value is below it anyway, because negative numbers for moving the opposite way and stuff, that's not going to be registered by the game as being pressed, which is very convenient. You can see now that my fingers are indeed off of them, and they are zeroed out as they should be, but now I'm going to start pressing on them, and they're going to start showing up. And it doesn't start responding until I'm about a quarter of the way to the right on the left stick, in this case. Or in this case, about a quarter of the way to the left. So that's really good. That's a good thing to have on hand. Now, you have these values. And now the real fun starts. Well, I say it's fun. Some other people may not think so. But the real fun starts. I'm going to bring up this example that I made a few days ago again. When you try and actually do anything with this. So the directions. This is going to involve a bit of trigonometry. Fortunately, I really don't know why I decided this was important to bring up, but fortunately GameMaker does actually give you a few functions to work with that could be kind of nice. You may be familiar with them already. I'll get into what they are later. But you do already have the horizontal and vertical for each of these. I'm going to set a couple of variables. So var, there we go. I'm going to still draw these on the screen because, well, why not? But they're going to be saved to these little variables here just for later use. And that later use is going to be, let's actually move this over instead of down. Anyway, underneath this, I'm going to draw some text. No, not yet. I'm also going to declare some values for direction. So we're going to be saying, how about LD for left direction and RD for right direction. LD is going to be actually quite simply point direction from 0, 0 to LH and negative LV. Alright, and RD is going to be pretty much the equivalent except for instead of left, naturally it's right. And here I'm going to draw text. If you don't get why I'm using negative L and R there, I'm going to explain it in a minute, don't worry. But it's going to go from, how about 32, 96. Alright, it's going to look somewhat like this. I'm going to copy it and paste it over here for the right direction, so 256. And instead of LD, it's going to be RD. And I'm going to do all my explaining in a moment, but we're going to run the game. And now, alright, let's see, I'm pressing all the way to the right on the left stick, and you can see it's 0. Up is going to be about 90, left is going to be 180, and down is going to be 270. And that's going to be rotating pretty much as the unit circle goes, if you're familiar with trigonometry, or if not, just the way all directions pretty much go in GameMaker and computer programming, with left being 180 and right being 0 and whatnot. Same for the right stick, so that's all working properly. Now, the reason that these are negative is pretty much just the fact that in computers, up is the negative y direction instead of the positive y, as they are on like trigonometry graphs and stuff. I'll do a little drawing and put it up on the screen now if you don't follow quite. But pretty much, if you were to get rid of these negative signs and hit up on one of the sticks, it would say up is equal to 270 instead of 90. It's not the end of the world, and in fact, you can program with that if you remember to account for it. But for the sake of like simplicity, it's generally better to have left and right being or rather the vertical values being inverted. Anyhow, moving on. You can also, if you want to, get like the intensity that you're pressing down on one of the sticks. So say if you're not pressing down on one of them like all the way, if you're only pressing like halfway to the left or whatever, I'm motioning in the air with my hands and I just pointed right for left. But maybe you want to like have your character moving slowly around, like walking. If you're not pressing all the way, you can say, let's just say LI for left intensity or whatever, and we're gonna be saying SQRT of LH times LH plus LV times LV, and we're gonna be doing the same thing for right. And if you're familiar with the Pythagorean theorem, which I'm assuming that most people are, if you're like above high school age, this is just basically going to be doing the Pythagorean theorem and making out these horizontal and vertical values to be the legs of a triangle, and the more you're pushing on them in one direction, the longer those legs are going to be. So the hypotenuse, which Li and Ri essentially are going to be bigger. It's going to be longer the harder you're pressing down on it. So I'm going to run that real quick, and I am not drawing it on the screen, am I? I got to draw that on the screen. Oh, that's weird. Okay, before I actually start, I realized that I got an error there because I was saying plus LV instead of multiply by. So that is actually the Pythagorean theorem. Sorry, you can laugh at me later. But anyway, you can see now the directions are showing up, and you can see now I'm only pressing a little bit in one direction, and you can see that it's being reflected between 0 and 1. So, like I said before, you can use that if you want to have like a character sneaking around and stuff. You may also be noticing that when you're pressing to about the corner, it's showing up as a value greater than 1. And that is quite simply because, well, if you were to look at it, if you remember, 1 squared plus 1 squared is going to be 2. The square root of 2 is about 1.4, which is greater than 1. And that's going to be giving a value that's greater than 1. And if you don't want that, if you don't want your character to be like sprinting, like at top speed, if you press like to about up or left or whatever, you can just say, instead of only the square root, you can say it's the minimum of 1 and the square root. So we're going to say min 1 square root there once again. So that way, if this value comes out greater than 1, the game is going to just say, oh look, this is greater than 1. 1 is the smaller number. We're going to take that because that's what the minimum function does. Anyway, demonstrate that, run the game, and you can see now I'm pressing to the corner, and it's still only saying 1, as it should. Alright, now there's only one thing left to do, I suppose, and I'm going to move the main room back over there. I am going to go and take this and stick it in a function for use later, so I don't have to type that all out when I want to use it later. So I'm going to say, how about let's just say GP left direction, and I'm going to copy this there, and I'm going to duplicate this and call this, no, don't do that, I don't want to open a script, I want to duplicate it. We're going to be saying GP right direction, and here I'm going to be excluding the left values for left direction. I'm also going to be getting rid of the intensity things, because we don't really need that now. We can just bring that back later if we want to use it. But anyway, let's see. In this function for the left, we're going to be getting rid of the right checks and stuff like that. All right. So we have these two set up for checking the directions. I am going to go back into the player object, and here, instead of checking for if you're pressing left on the D-pad, I'm going to be saying if GP left direction is greater than or equal to 135 and GP left direction is less than 225. And if this is a little bit like confusing to you, if you have no idea what I'm doing here, just think about the unit circle again, or well, I should probably say to make it simpler, the directions the GameMaker uses, with the left being 180 and stuff like that, and up being 90 and down being 270, whatever. And the corners, well, I shouldn't really say corners because this is a circle and circles don't have corners, but halfway between up and the left would be 220, would be 135, and halfway between left and down would be 225. So pretty much, if you're pressing anywhere between those two values, you're going to be wanting to move left. Pretty much the halfway points, I guess, is what I'm trying to get at here. And I'm going to just copy and paste this real quick for the other three directions. Alright, there we go. Now, the only thing left is going to be, well, very funny puns, right? But we're going to have to do a little bit of special writing for that. Because right is the area where it kind of gets cut off, where it flips, where the direction is going to flip back from 359 to 0. We can't just say greater than something and less than something, because that's never going to happen. You're going to have to be less than 45, no, greater than 315, or less than 45. Yeah, there we go. Obviously, right is going to be detected between 0 and 45, and also between 315, the direction, and 359. And obviously, you can't have both of those happening at the same times. At least I hope that's obvious. Anyway, so I'm going to be hitting the game. Oops. No, we're not going to be hitting the game yet. I should do, instead of... I should be returning this value instead of just setting it to a variable and then doing nothing with it. But, see, we're going to return point direction for left, and we're going to return point direction for right. Alright, so we'll pretend that that last one never happened. Anyway, so let's see. I'm hitting left, and I'm hitting up, down, right, and it's all working the way it should be. Almost. So you may be noticing that my finger is supposedly not pressing on anything, and he's still moving to the left. And that's because when you go into this function, when you go and take the direction, when you're not pressing down on anything, this is going to be 0. This is going to return 0 as well. And when you go and take the direction of 0, 0, 2, 0, 0, it's going to spit out the number 0 itself. And then when you go into here and you ask for the direction that it's giving you, if you're not pressing down anything, it's going to give you the value of 0, which is going to happen to be going left. And to account for that, we can say ahead of time. There may be a more efficient way of doing this, but this is the only one that I can think of. If you can think of another solution, by all means, let me know in the comments. And I'll definitely be interested in seeing it. But we're going to be saying if LH equals 0, I'm going to give this a space to make it a little neater, and LV equals 0, so if the stick should be snapped to the beginning, instead of returning a number that's just calculated with the point direction, we're going to be saying return -1. And we're going to be doing, even though we're not using this particular function in this this example here, the same thing for right. And I'm going to be getting out of that. And here, we're going to be saying if, in addition to this going on, but if GP left direction is not equal to -1, and all that is happening, if the stick is snapped to the middle, this function is going to return -1, and this if statement is going to detect that the function has returned -1. So this is not going to be true, and it's not going to do anything with it. So we're going to run the game. This should be working. And it isn't. Oh, I know what's going on. Yeah, logic tables. The game was comparing these two at the same time, and it was checking that -1 was greater than 315, or -1 was less than 45. And since it's less than 45, this statement evaluated true, and this got overridden. So to deal with that, we're just going to throw some parentheses around there. If in doubt, always use parentheses when you're programming stuff, because it's going to make things easier. But anyway, now it's working as it should be. I'm not pressing anywhere, and I'm not moving anywhere. I'm pressing up. I'm going up, left, left, down, and right. I'm walking up to you. I'm hitting A, and I'm talking to you as I should. And pretty much everything is working the way it should. There isn't all that much left to do with controller programming. Probably nobody is going to be interested in how this works in 8.1. It's basically a simplified version of how this works here, except with a lot more restrictions of things that you can use. It's honestly a lot more annoying. In the rare case that anybody actually wants to know how that works, let me know and I will make a video on it. But for now, that has been controller input. I think it's a very valuable tool. I think it's a lot of fun. I know a lot of people, including me, do like to use controllers for their games most of the time over mouse and keyboard. So I hope you all found that useful. If there's anything else you'd like me to cover, let me know and I'll put it on my list of things to do. But for now, Rate, comment, and subscribe if you want either of these files that I've used in this video here, this NPC thing one, or the one that's just a list of all the commands. There will be links to download those in the video description. So yeah, I'll see you all later. Okay, Steam, I will say this is rather annoying.